Alright, so this is one of the problems one like this that you might see on your calculator portion of your test, where you have to graph. You're going to give me the vertex, the axis of symmetry, domain, range, x-intercepts. Remember, x-intercepts are the same thing as zeros. It's the same thing as factoring and solving for x. And the one nice thing about this problem being on the calculator portion is you could use your calculator, and actually with this one, you can pretty much do everything you need to do with your calculator. But we're going to do this one by hand because it's going to be easier for the video. First things first, since I need my x-intercepts, I'm going to go ahead and factor this problem. Okay? So I'm going to factor it. But the first thing I want to do is this negative number kind of freaks me out a little bit. I want to get rid of it. So I'm going to have my f of x equals, and the way I can get rid of a negative in front of my x squared is I can just factor out a negative 1. I get x squared plus 6x plus 5. Now all I need to do is worry about this part right here. I'm going to factor that part using my method where I do like the little x with the 5 up top and the 6 in the bottom, because I want to multiply to 5 and add to 6. So what that's going to look like is, I'll do it down here because I have more room, multiply to 5, add to 6. Well, if I multiply to 5, add to 6, I'm going to go with 5 and 1. So what it's going to look like is this. X plus 5, x plus 1, and I am factored. So I get my 2x intercepts now by solving each one of these factors. So I'm going to have x plus 5 equals 0, and I get x equals negative 5. So that's one of them. And then I have x plus 1 equals 0, and I get x equals negative 1. So those are my x-intercepts. And I can go ahead and plot those. So I have negative 5. And I'm also going to have negative 1. Now I can find my vertex. I can use the negative b over 2a method with this guy here. Or if I'm looking here, well, I've got negative 5 and I've got negative 1. Well, right between that is negative 3. So my vertex is going to be somewhere along this line here. Well, my x-coordinate is negative 3. So I know that my x has to be negative 3 for the vertex. And how do I find the y? I can just simply plug it in. So if I plug that into the original equation, you could use the original, you could use the factored version. I'm going to use the original. So if I do that, I have negative, parentheses, negative 3 squared minus 6 times negative 3 minus 5. And we have, let's see here, negative 9 plus 18 minus 5. So negative 9 plus 18 gives me 9. 9 minus 5 gives me 4. So we get 4 here. So my next point is negative 3, positive 4, right up here. Draw my parabola. Well, my axis of symmetry is going to be right through the vertex, so I'm going to get x equals negative 3. My domain is always all real numbers when we're doing parabolas. In my range, I look at my vertex here, and I know that it can't go above that because the graph is pointing down, so y has to be less than or equal to my 4, because that's where I'm at. So I get y is less than or equal to positive 4. We got everything that we needed, and we're done. If you wanted to, with this type of problem, you could plug it into your y equals on your graphing calculator, and you would see that it crosses here, oops, and also over here. Alright? So you can see that it crosses at these two spots. You'd actually be able to count it. You'll be able to see it because they're actual numbers there. They're not like decimals. So they're integers, so you'll be able to count it out. Whereas if it was decimals, you really can't approximate. So we're going to see it cross at negative 5 and negative 1 in your calculator. You'll get your x-intercepts, and you can even find your maximum of this parabola in your calculator by doing the max left bound, right bound guess. All right?